Our example problem here, we have a 4.5 kilogram weight. It hangs from a vertical massless ideal spring. When set in vertical motion, the weight obeys the equation y of t equals 6.2 centimeters times the cosine of 2.74 radians per second times time minus 1.4 radians. So we want to find three things here. A, what is the period of the weight's motion? B, what is the maximum speed of the weight? C, what is the spring constant of the spring? So if we compare this to our generic equation that describes simple harmonic motion. Now we have y of t given, and that's because this mass is oscillating vertically, so they're just using a y to represent up and down, where we've been using x, but x could technically represent up and down if we wanted to. But comparing these two, we have the amplitude is going to be 6.2 centimeters. Because that's the term in front of the cosine function. Within the cosine function, the number in front of t is omega. So omega, 2.74 radians per second. And in this particular case, phi naught, the phase shift, is negative 1.4 radians. So by looking at this equation, we can identify what these numbers mean. All right, so part A, we want to know the period. Well, omega and period are always related. Omega is 2 pi f, so 2 pi over the period. That means our period of motion is going to be 2 pi over omega. We have omega, that's 2.74 radians per second. So by plugging that in, so 2 pi, let's see, we have 3 sig figs, so 2.29 seconds. The 2 pi's in radians, radians cancel, the period, 2.29 seconds. So B, the maximum speed. Well, we have our equation that describes the position. The velocity is going to be the derivative of that. Derivative of cosine is negative sine. So negative 6.2 centimeters sine of all this stuff. And then times the derivative of what is inside the parentheses. I'm going to put that in front of the sine function. Whatever is in front of the sine represents the maximum value. So the maximum speed would be 6.2 centimeters times this 7.4 radians per second, which gives us 16.988, but to 3 sig figs, that 9's going to round up. Our units are going to be centimeters per second, because I left the amplitude in centimeters. Now, we did talk earlier video that Vmax is omega times A. You could totally use that from the get-go if you'd like. That's ultimately what we've done. All right, so that is the maximum speed, 17 centimeters per second. Part C, what is the spring constant? So we want K. Mass spring system, I know that omega is the square root of K over M. They did give us the mass, so coming back to the problem, the mass is 4.5 kilograms, and as we've already used, we know omega, so let's go ahead and plug those in. If I square both sides, omega is the square root of K over M, so K is going to be omega squared times M, so 2.74 squared times 4.5. So to 3 sig figs, this is 33.8. Our units, to find the units from just the numbers we plugged in, the mass was in kilograms, the omega was radians per second squared, so we can easily write that as kilograms per second squared. It's also a Newton per meter, so that would be perfectly valid. But by just looking at the units that I've plugged in, I would write it as kilograms per second squared.